In a previous video, I laid out two big requirements for my voting system. Number one, we should be able to ensure that a single contributor cannot vote multiple times on a single spending request. Okay. So for example, let me go, let me show you this diagram that I showed you earlier. So here we see Bill voted one time with a yes, Jane yes, Alex yes, but then we see Amanda is trying to vote no 3 times on the same request here. So we absolutely want to avoid this behavior. A contributor should only be able to vote one single time on any given request. Number two, we should ensure our voting system can accommodate thousands of different people voting, as marked by this diagram here. So with those requirements in mind, I'm going to show you one possible way of putting together this voting system. I'm going to show you the wrong way to design this voting system. Now, why would I bother showing you the wrong way? This wrong way is what I expect a beginner of Solidity might do to design this voting system on their own personal project. I'm going to go over why we would design it that way as a beginner and why it's wrong. So I'm going to show you this wrong way so that we can be aware of these gotchas. All right, so let me pull up one of those, a diagram for that wrong way. And this one here. All right, so here's one way that we might start to lay out some data inside of our contract to address the fact that we want to have many people voting and ensure that anyone can only vote one time on any given request. On the left-hand side, I have the address of arrays of all my contributors, and I already have this data structure. So that's the approvers array, and it's an array of addresses. So this is everyone who has ever donated to a contract. In fact, instead of showing you this diagram, I actually wrote it out here. So I'll show you this here. All right, so to address the issue that people can only vote one time on any given request, maybe we can create a second array that exists inside of each request struct. So this address array might record the address of every person who has voted on this request already. So the address array will start off as completely empty, and once people start voting, we add their address to this array. So whenever they vote, we will increment some counter and we'll increment the counter of yes or no, and then anytime they attempt to vote in the future, we'll look at the address and see if it already exists inside this array. If it does exist, then they already voted once and we should not allow them to vote again. So this seems like an obvious way of doing it, right? So let's take a look at how I might write the approve request function, right? So here I have the approve request function with this type of design. So this is one possible way of writing out a proof request with that type of data structure. So inside of here, the first thing I do is check to see if this person has ever donated to the campaign, right? And if not, then we don't want to allow them to vote, okay? So we have not looked at a for, so this, you're seeing I have a for loop here, and I know we haven't looked at a for loop inside of Solidity, but it's similar to JavaScript. So we assume they have not donated, we loop through our approvers array, and if the address is that's inside the array, then we flip the isApprover flag to true. If the address is not inside the array, we flip the approver flag to true. All right, so the second thing that happens is we ensure the person has not voted before. I'm sorry, I had it backwards. So if the address is in the approvers array, if it's inside that array, we flip the isApprover flag to true. That's what I meant to say. I was getting ahead of myself because it's a little bit different when we get down here. So the second thing that happens is we ensure the person has not voted before. And so we have this request struct here, and it has a list of people who have voted. And we loop over that array and we ensure the person's address is not present in there. If it is, they have already voted and we kick them out. So this is just one possible way of implementing it. So in a subsequent video, I'm going to tell you why this implementation is a poor way of writing the contract. I will see you then.